Hi dears, today we can see some problems on complex analysis from CSIR NET. So the first question here is, let I is equal to integral 2x square plus y square dx plus e power y dy, where C is the boundary, okay, oriented anti-clockwise of the region in the first quadrant, bounded by y equal to 0, then x square plus y square equal to 1, then x equal to 0. Then what about the value of the integral? So for that, the question here is bounded by C, right? So accordingly it is given y equal to 0, x square plus y square equal to 1 and x equal to 0. So x square plus y square equal to 1 means it is definitely a circle. So with the radius 1, okay? So here 1 and here minus 1. So this is a circle with the radius 1, okay? And then it is given y equal to 0. So that this is y equal to 0, x equal to 0. Okay, right. Now, this is a portion C, boundary. Okay, now we have to see this integral. The question it is given here as I is equal to integral 2x square plus y square into dx plus e power y into dy. It looks like integral m dx plus n dy. So we know that by Green's theorem, we can write this as integral over m dx, integral over c, m dx plus n dy is equal to double integral over the surface dou m by dou x minus dou m by dou y into dx dy. Okay, so first of all we can find dou m by dou y. So m is here is what? 2x, m is equal to 2x square plus y square. So the dou m by dou y is equal to 2y. Similarly, dou n divided by dou x is equal to, here n is equal to e power y. So here there is no x term, so that is equal to 0. Substitute these value in this integral. So that equation 1 implies in the place of m, that is 2x square plus y square into dx plus n is e power y into dy equal to double integral over s, that is dou m by dou x is 0, then minus, right? So that you can put here as minus, then dou m by dou y, which is equal to 2y into dx dy. So now we are going to write the limit. So you can see this figure, x is equal to 0, here x is equal to, radius is what? 1. So x is equal to 0 to 1, okay? X varies from 0 to 1. And what about y varies from, here it is 0, okay? Here it is 0 because y is equal to 0 line and this is the boundary. So we know this boundary is what? X square plus y square is equal to 1. So what about y square, which is 1 minus x square? So y is equal to plus or minus root of 1 minus x square. In the question it is given, take only the first boundary, first quadrant. So you have to take the positive one, that is 0 to root of 1 minus x square. So here you can write x varies from here 0 to 1 and y varies from 0 to root of 1 minus x square. So that which is equal to minus 2 integral 0 to 1. Here it is y square divided by 2 from the limit 0 to root of 1 minus x square into dx. Okay. So that which is equal to minus 2 integral 0 to 1. So that this become 1 minus x square divided by 2. So that get cancelled into dx. Okay. So that again we are doing the integration x minus x cube divided by 3 from the limit 0 to 1. So which is equal to minus 1 by 3, which is equal to 3 minus 1, which is 2 by 3. So it is minus 2 by 3. So you can see the option minus 2 by 3, that is option B is the right one. Let's see the next question. Yeah, the second question. Principal part of minus 1 the whole power minus 2y divided by pi is. Principal part of. So here you can write minus 1 can be written as what? Cos pi plus I sin pi, right? Because sin pi value is 0, cos pi value is minus 1. So you can write this way, right? Minus 1. And this you can write as Euler's formula is e power I pi, correct? E power I theta, which is equal to cos theta plus sin theta. So in short, we can write minus 1 is equal to e power I pi. So the question here is minus 1 the whole power minus 2i divided by pi. So that minus 1 is e power I pi the whole power minus 2i divided by pi. So pi and pi get cancelled. You will get e power minus 2i square. So I square which is minus 1. So that you are getting e square is the answer. So accordingly option A is the right one. Next question. Question number 3. Let f from C to C be an analytic function with f of 0 is equal to 1, f of 1 equal to 2, f dash of 0 equal to 0. Right? Okay. There exists n greater than 0 such that modulus f double dash of z less than or equal to f, that is bounded. Then f z is what? Not f z, f of 2. Yes, f of 2 is what? That we have to find it. So see here, f is an entire function. So f is entire function. So the second condition it is given, it is bounded, right? So the function is bounded. So we know that if a function is entire and bounded, then accordingly f is a constant function by using Liouville's theorem. Okay, so definitely you can say that f is a constant function. F is a constant. So option A or B is the right one. Okay. So we have to choose accordingly a function, that is f of z is equal to, I am taking here as z square plus 1, because this should be satisfied these three conditions, that is f of 0, let's check this one, while I am putting f z equal to 0, f of 0 equal to 1, right? The first condition gets satisfied. Then z is equal to 1, substitute f of 1 is equal to 1 plus 1, 2, second condition satisfied. Let's check the f dash. So here f dash of z is equal to what? 2z. Let's substitute the third condition, f dash of 0, which is equal to what? 0. So three conditions satisfied. Accordingly, I took this one. Okay. So this is a function. This is a function. So these three conditions satisfied. Hence I can able to do f of 2. F of 2 is equal to 2 square plus 1, which is equal to 4 plus 1, 5. So you can say that option B is the right one. Option B, right one. If you difficult to find this function z square plus 1, you can take the function f z is equal to the general one, a z square plus b z plus c. Since I am taking these three constants, because here we have three conditions, right? So let's check these three conditions here. F of 0 is equal to 1. So here f of 0 equal to 1 means implies a into 0, c is equal to 1. Okay, let's next f of 1 is equal to 2. It is given in the question. F of 1 is equal to 2. So that is implies f of 1 that is equal to 2 is equal to a plus b, c value is 1. So this implies a plus b is equal to 1. Okay, then check the third condition. The third condition is f dash of 0 is equal to 0. F dash of 0 is equal to 0. Okay, so that f dash of 0 is equal to 0. So what is f dash of z here? That is 2az plus b. Okay, so that f dash of 0 is first one 0, then b equal to 0. Substitute this value here. Okay, that is equal to 1. So I get here a equal to 1, b equal to 0, and c equal to 1. This I am substituting in this function. Okay, so that f of z is equal to a value 1, z square, b value 0, and c value 1. So what I am taking at the beginning, you see that the function which I took at the beginning is z square plus 1. So directly you can write that f of 2 is equal to 2 square plus 1, which is equal to 5. So option B is the right one. Let's check the next question. Question number 4. The image of the half plane real z plus imaginary z is greater than 0 under w equal to z minus I divided by z plus I is. So 4 option is given. The condition here given as a real part of z and the imaginary part of z is greater than 0. So first it is given of the question w is equal to z minus I divided by z plus I. So which is equal to, usually z is equal to x plus I y. But the condition here given as real part of z plus imaginary part of z is greater than 0. So I am taking here 1 plus 1. Okay, so that 1 plus 1 which is greater than 0. So that z is replaced by 1 plus I. Again here minus I is here divided by 1 plus I plus I. So this is equal to 1 divided by 1 plus 2y, and I am taking the conjugate, so that 1 minus 2y divided by 1 minus 2y, which is equal to 1 minus 2y divided by 1 square plus 2 square, right? Which is 1 by 5 minus 2 by 5 into I. So what is the real part of W, which is equal to 1 by 5? What about the imaginary part of W, which is equal to minus 2 by 5? So here we can check this option. Real part of W is greater than 0, right? So it is greater than 0. Option A is true. Imaginary part is greater than 0. That is wrong. Okay, option B is wrong. Let's check modulus of W. Okay. So modulus of W is equal to, this is W. Okay. So root of 1 by 5 the whole square, then plus minus 2 by 5 the whole square, which is equal to root of, yes, definitely the positive one. 1 divided by 25 plus 4 divided by 25, which is equal to root 5 by 25, which is 1 by 5. Yes, definitely it is greater than, C is greater than 1. It is not possible. Here it is greater than 0. So we can say that option C, that is modulus W greater than 1, is the wrong one. So, but modulus W is less than 1, because here root of 1 by 5, which is less than 1. So according to this question, option A is right, then option D is right. Other two options are wrong options. Let's see the next question. Let gamma be the circle by Z is equal to 4 e power I theta, where theta varies from 0 to 2 pi, then integral over C e power Z divided by Z square minus 2Ez dz is equal to. So we have Cauchy's integral formula, integral over C Fz divided by Z minus A into dz is equal to 2 pi I into F of A. Okay. So here we have the integral over C e power Z divided by Z square minus 2Z dz can be written as integral over C e power Z divided by Z into Z minus 2 into dz. So we have to split this one by using partial fraction method. So partial fraction, 1 divided by Z into Z minus 2 is A by Z plus B divided by Z minus 2. That is A into Z minus 2 plus BZ divided by Z into Z minus 2. So these two get cancelled. So here 1 equal to, right? 1 equal to A Z minus 2 plus BZ. First I am putting Z is equal to 2, so that 1 equal to 2B implies B equal to 1 by 2. Let's put Z is equal to 0, 1 equal to minus 2A. This implies A equal to minus 1 by 2. So this will be splitted as using this, okay? Integral over C e power Z. What is the value of A? A here is minus 1 by 2. So minus 1 by 2 into dz, okay? Divided by Z, A by Z, okay? The value A is here divided by Z. Then plus integral over C, B divided by Z minus. So here already e power Z dz is there. B, what is B here? 1 by 2 divided by Z minus 2, okay? So which is equal to minus 1 by 2 common for both. So integral over C e power Z divided by Z minus 0 into dz. Here plus 1 by 2 into integral over C e power Z divided by Z minus 2 into dz. So according to the Cauchy's integral formula, you can write that, which is equal to minus 1 by 2 into 2 pi I into F of A. What is A here? 0. F of 0. Then plus 1 by 2 into 2 pi I into F of A. A is here 2. So that this is equal to minus 1 by 2. So these two get cancelled. Minus pi I into, what is F of 0? F is nothing but this one. Okay, this is F of Z. So substitute the value e power 0, which is 1. Then plus 1 by 2, that also get cancelled, which is pi I into F of, that is E square, right? E square. So from this both I can take pi I common outside. So E square minus 1. So pi I into E square minus 1. Pi I into, yes, option C is the right one. Pi I into E square minus 1. Hope it helps you. Thank you.